In this video, I'd like to talk about the first of three what I call essence properties associated with components of simulation models. If you spend a moment and look at all of the pictures on this page, there's something they all have in common, even though they're actually very different representation. They're pictures of very different kinds of things. Did you get it? They all represent a quantity of something. This is a quantity of garbage in a dump, or a quantity of coffee in a cup, or a quantity of water in a lake, water in a pool, a quantity of rabbits in a population, quantity of sand in a pile, money in a savings account, or ice in a glacier. So that it's very different kinds of things, but each one of them represents a quantity of something that it took time to accumulate and would take time for it to dissipate or go away. The rabbits develop based upon the population develops based upon birth, and the population declines based upon death. The water in the pool increases based upon someone filling it. It decreases based upon evaporation or people actually being in the pool and taking water out with them as they leave. So we can go ahead and represent that quantity of stuff by something called a stock. And just remember that a stock represents a quantity of stuff that doesn't change instantaneously. It only changes if something flows into it or something flows out of it. And the flows in and flows out are over time. Remember the over time part, because it's very important and it will resurface over and over and over again. One of the big difficulties that we have in terms of understanding the way that things interact and behave is the sense of accumulation. And you'll see that in this model and in the next two, in that understanding the nature of what happens as things accumulate or dissipate over time. Again, the over time part is sort of non-intuitive quite often, and it's the non-intuitive part that tends to get us in trouble all the time. So in this particular situation, we have a stock, which is a quantity of stuff. It increases when something flows into it, and it decreases when something flows out of it. So if we turn this into a simulation where the stock starts out at a value of 10 right here, and the rate at which something flows into it is 2, and the rate that something flows out of it is 1, because the inflow is greater than the outflow, the amount of stuff that's in the stock increases over time. And this is a time period of 10 years. And the time period is different for different things that you're simulating. Here, it's just a quantity that was picked to use as an example. So the idea is just to realize that it takes time for the content of a stock to change, because it represents an accumulation of stuff, something that flows in, flows out, and happens over time. If the outflow is greater than the inflow and the stock started at 10, then over time the value of the quantity of what was in the stock would decline over time. And in this instance, because the outflow is 1 greater than the inflow, over a period of 10 years, the stock actually declines from 10 to 0. If the inflow and outflow were the same, the amount of, or the quantity in the stock wouldn't change. What the stuff actually was would change, because there's stuff flowing in and stuff flowing out at the same time. So what's in the stock changes, but the amount of stuff in the stock doesn't change. So this is sort of a situation where it represents growth or decline, but the growth or decline is not dependent upon the quantity of stuff. And this is you will run into this at times, though generally the stock will be dependent upon the inflow or outflow one way or another. So this is what I refer to as essence property 1. I would suggest that you go to the external resources, go to this model, and actually interact with it, change the value of the stock, the inflow and outflow, and run the simulation until you're comfortable with how changing the inflows and outflows actually have an impact on the way that the stock changes over time. Hope you found this interesting, and I'll see you in the next video. Bye.